Hey there, Mr. Weaver here, and this is Topic 4B, Lesson 4, Graphing Inequalities of Two Variables. After this lesson, you need to be able to graph a two-variable inequality on a coordinate plane using the correct line type, and you need to be able to determine if a coordinate is part of the solution set. You'll know you're successful if after this lesson you can graph the line represented by the inequality using a solid or dashed line, shade the area that represents the solution set of the inequality, and determine if a coordinate is considered a solution. First, let's look at our steps for graphing inequalities. It looks like there's a lot of information here. However, there's really only 3 steps. So, first step, you're going to graph your inequality as if it was an equation. So, just like we were graphing lines back in Topic 2, Lesson 8. But this time, we're only going to graph the dots, not the line itself, at least not originally. So remember that y equals mx plus b, where m is your slope telling you how much to go up and over, and b is your y-intercept or your start point. Once you've graphed the dots where your line should be, then you're going to look at the inequality symbol and determine what type of line you need to use. So if you see the greater than or less than symbol with no line underneath it, then you're going to draw a dashed line. This is similar to the open circle where it's not filled in. So this is a line that's not filled in. If you see the greater than and equal to or less than or equal to, then draw a solid line where it is filled in. This is like the closed circle of our single variable inequalities. Once you have those drawn, then you're going to determine where to shade. You are going to shade based on y. So if y is greater than or equal to, then you're going to shade above. If y is less or y is less than or equal to, then you're going to shade below. So some of the things here follow some common sense. One thing, if you happen to see a negative number in front of y, so like maybe it's negative y equals 3x plus 2, that's going to switch it. Think about what we just did. If you had to divide by a negative, it flips the sign, which would just mean you're going to shade the opposite. Now, that's not super common, but it is there as a reference. For the next two, these are not common at all, and only use these if you don't have a y in your inequality. Okay, so if x is greater than or equal to, then you're going to shade to the right. If x is less than or equal to, then you would shade to the left. Again, don't use those unless there's not a y in the inequality. After we've done all of our graphing, so we graphed our line, we shaded it in the correct spot, then we need to determine if coordinates can be solutions. So a solution to what we graphed is any point that happens to fall in the shaded region, or it can be on a solid line. Okay, so shaded region, solid line. That's similar to like it would fall in the arrow or in a closed circle. If the point is on a dashed line, however, it is not included. This is similar to the open circle of our number line graphing where we don't include the answers that are on the open circle. Let's look at a couple examples. I did use Desmos to graph these, so just know that that is an option to help you check to see if you're doing things correctly. So y is greater than negative 2x plus 4. So first, I'm going to pretend that was an equation and graph the line. So I'm going to start my y-intercept at plus 4. Then my slope is telling me to go down 2, and then it's a secret fraction over 1. So down 2 over 1, and I would make another dot. I would continue following that pattern until I start to form a line out of my dots. Next, I need to connect the dots. So to do that, I need to determine which type of line to use. Based on the symbol that's there, it's just a greater than symbol. So I would need to make it a dashed line. Finally, I'm going to see how y is related in this problem. So y is greater. If we come across that, greater numbers are above, so we need to shade above the line. Sometimes your lines are a little difficult to tell if it's above. Draw an arrow straight up from any point on the line. Eventually, you'll be able to figure out where it needs to be. So this would be the graph of our inequality. Y is greater than negative 2x plus 4. Now it's your turn. Pause the video and see if you can figure out what the graph of y is greater than 3x minus 2 looks like. Let's check. So first you should have graphed your line starting at negative 2, going up 3 over 1 each time. It's a dashed line because our symbol is just greater than. And you should have shaded above it because y is greater. So even if it looks like the shading is on the opposite side, left versus right, that's not what matters. We're shading above the line. Let's look at another example. So y is greater than or equal to 1/3 x plus 2. Again, I need to graph as a line. So I start at plus 2, go up 1 over 3 each time. This time I have a greater than or equal to symbol, which means I would make it a solid line. When I look at how y compares, y is greater or equal to, so that y is greater means above again, so I shaded above. This one looks more like it's above than the other examples, but all of them have been above so far. Before you pause the video and do this next problem, please change the symbol from the equal sign that's mistyped in your book to less than or equal to. So your problem should be y is less than or equal to 3/4 x plus 2. Pause the video, figure out the line. What does the graph of this inequality look like? Let's check. So you should have graphed your line 3/4 x plus 2, starting at 2, going up 3 over 4. This time, y is less or equal. So this is the first one where we are going to shade below. For this next example, let's enlist the help of Desmos. In Desmos, if we type in our inequality, it graphs it and shades it for you. And it chooses the correct line. So that can be very helpful when you're trying to determine if you've shaded things correctly. Now, we want to determine if our points are solutions. So they need to be in the shaded area or on a solid line. We have a dashed line here, so they can't be on that line. I'm just going to type in my coordinates. So 4, 5. If you notice, it is up here in the shaded region. So 4, 5 is one that I would choose. If I check the next one, I have negative 2, 3. This one is also in the shaded region, so I would choose the second one as well. If I check the third one, 2, negative 4, notice it is on the dashed line. That cannot be a solution. So the third one is not good. Let's check the last one, 8, 4. I can see that it is outside the shaded area. It is also not a solution. For our inequality, the top two were our solutions because they were in the shaded area. The bottom two were not. Now it's your turn. Pause the video and determine if the 4 coordinates given are solutions to the inequality. Use Desmos to help graph your inequality so you can easily check to see if the points are solutions. Let's check. When you graphed it on Desmos, you should have had a graph that looked like this. If we check each of the points, there are their locations. So the first one is on the line. That's the only one that's really in question. 2 of them are clearly in the shade, 1 is not. What about the one on the line? It's a solid line, so it was okay. So you should have chose the first one and the last 2 as ones that are solutions. The second one is not, it is outside the shaded area. In this lesson, we learned how to graph a linear or 2-variable inequality, meaning it has an x and a y. For these, your solution set is the shaded region. And to get this, first you just graph the inequality as if it was a line. Then you choose what type of line. So depending on what symbol, you're either going to make it dashed or solid. Then you need to decide if you're going to shade above or below, depending on how y is related in the situation. And then when you want to determine if a coordinate's a solution, you just need to look, is it in the shaded area? Or is it on a solid line? Okay, if it's in those shaded areas or on the solid lines, it is a solution. If it's on a dashed line or in the not shaded area, it's not a solution. And that's really all there is to graphing linear inequalities. So after this lesson, do you now know how to graph linear inequalities on a coordinate plane with the correct line type and shading? And can you determine if coordinates are considered solutions? If you're not sure about these things, go back and look at some of the examples and focus on how we knew which line to choose, where to shade, and what is considered a solution and what is not. And that's the end of lesson 4 on graphing 2-variable inequalities.